This accompanies the OpenStax College Algebra book. This is from section 2.1, the rectangular coordinate system and graphs. So first we're going to look at a grid and we're going to talk about that, and then we'll start plotting some ordered pairs. So this is the rectangular coordinate system. You can see that you have the x-axis here, it's the horizontal axis, and then you have the y-axis here, it's the vertical axis, and you will use those axes in order to plot points. So for the following examples, we want to plot the ordered pairs, then we want to name the quadrant in which the point would be located. So -3, -4. I'm going to do that one in blue. So -3, -4. Keep in mind when you're plotting points that an ordered pair is x comma y. So the x value always comes first in the ordered pair and the y value comes second. So since the x value comes first, that's going to tell you how far left or right you move, and the y value will tell you how far up and down you move. You always start at the origin. The origin is in the middle. Okay, so that is the origin. And that ordered pair is 0, 0. So that's the origin. So for -3, -4, you're going to start at the origin, and the -3 means you're going to go to the left 3 units, and then the -4 says you're going to go down 4 units. So there is the point for number 1. Now it asks us to name the quadrant in which the point will be located. So your quadrants are as follows. You start in the positive, so the upper right hand side. This is quadrant 1. And then you're going to go counterclockwise. So quadrant 2, quadrant 3, and quadrant 4. All right. So looking at that, we can see that point 1 is in the 3rd quadrant. So it's in quadrant 3. All right, let's look at number 2. So number 2 is -5, 0. I'm going to go ahead and keep working these in blue. So -5, that's the x value. So that's how far you go left or right. Since it's negative, we're going to go left. And then the 0 is up and down. So it will just go left 5 and then up and down 0. So there is point number 2. That is not in a quadrant. It lies on the axis between quadrants 2 and 3. That's on the x-axis. So that's what you would write down. All right, number 3 is 1, -4. So we're going to go right 1, down 4. So there's point 3. And you can see that that is in the 4th quadrant. Number 4 is -2, 7. So -2, left 2, and then +7, up 7. So there is point 4, and that is in quadrant 2. All right, and then last we have number 5 is 0, -3. So 0 left and right, down 3. So there is point number 5. And that is on the y-axis. So a lot of times students get confused with number 2 and number 5. So you have to remember which way you're moving for each point, right? So the 0, if it comes second, means up and down 0. The 0, if it comes first, means left and right 0. All right, so that's kind of a brief introduction to the coordinate system, how to plot points, the quadrants, the origin, ordered pairs, all of that. All right, so now let's look at this next part. Find and plot the x and y intercepts and graph the straight line based on those 2 points. So here we're given an equation and we want to find the intercepts. So let's quickly look up at this example again. Number 2 and number 5. These are both on the axis, right? So if it's on the x-axis, that point or ordered pair is considered to be an x-intercept. So it's called an x-intercept because it intercepts the x-axis, right? And this, if it's on the y-axis, would be a y-intercept. So notice that for the x-intercept, the y value is 0. That will always be true for an x-intercept because in order for it to lie on the x-axis, the y has to be 0. It has to have moved up and down 0. Likewise, for the y-intercept, the x-coordinate always has to be 0. So we're going to use that information to find x and y-intercepts. So if we look at number 6, okay, in order to find the x-intercept, we know that y has to be 0. So what we're going to do is plug 0 in for y and solve to see what x is. So 4x minus 3 times 0 equals 12. So that's just going to be 0. So that'll be 4x equals 12 divided by 4. So x equals 3. So when x is 3, y is 0, that is our x-intercept. And now we're going to plot that. So that's 3, 0. Okay, and now I'm going to do the same thing for the other intercept. So to find the y-intercept, I know that x has to be 0. So I'm going to plug in 0 for x. So 4 times 0 minus 3y equals 12. That's going to be 0. So negative 3y equals 12. Divide by negative 3. So y equals negative 4. So when x is 0, y is negative 4. So that is my y-intercept, 0, negative 4. All right, so whenever you want to find an intercept, you want to let the other variable be 0. And now I can graph the straight line that goes through these points. All right. So you can always use intercepts to graph a line. If you find the x and y intercepts, you can graph. Now this isn't always a logical way to do it, especially if you have large numbers, because they both might not fit on the same graph that you can draw. So this works in theory, but sometimes it's not realistic to do it this way. But this is a method to use to graph a line. All right, so the next thing we have is solve the equation for y in terms of x. So solve the equation for y in terms of x. So we want to get y by itself. That's what this means. So in order to get the y by itself, we need to move everything else away. So we're going to start by subtracting the 3x from both sides. That zeroes out, so we have negative 2y equals negative 3x plus 6. And now I want to get rid of the negative 2 in front of the y. So I'm going to divide everything by negative 2. So that'll give me y equals negative 3 over negative 2 is positive 3 halves x. And then 6 divided by negative 2 is negative 3. All right, so now I have the y by itself. So that is done. All right, you need to make sure you know how to do that. So this equation is given to you in standard form. And we will talk more about this in a coming section. And this is now in slope-intercept form. And we often like equations to be in slope-intercept form because you can tell the slope and the intercept, the y-intercept, just by looking at the form here. And again, we'll talk about this more in a coming section. Okay, so the next thing, if you have 2 points, you may want to know what the distance is between the 2 points. And so that is what we're going to do for number 8. So we have the distance formula here that's given. If you have 2 points, the distance is given by this formula. Okay. You do need to memorize this formula. You will not be given the formula on any kind of exams that we have, so make sure you memorize this. I would advise you to start making a formula chart just to help you study. So this is something I would put on the chart. All right, so find the distance between the 2 points. Write the answer in exact simplest radical form, then write the answer as a decimal rounded to the nearest hundredth. All right, so let's start by using the formula. So the distance is x2 minus x1, so 5 minus a negative 3 squared plus y2 minus y1, 17 minus 7 squared. Now it doesn't matter which you choose to be your x1 and x2, just make sure you're kind of consistent with those. So I just, by habit, I use the second point as the 2's and the first point as the 1's, but you don't have to do it that way. So let's see what we get here. So 5 minus a negative 3. Remember, the two negatives end up making a plus a positive. So that's really 5 plus 3. So that would be 8. So 8 squared plus 17 minus 7 is 10. So that would be 10 squared. That would be 64 plus 100, which would be 164. Now, there is the radical form. However, we need to make sure that is simplified. If you don't know how to do this yet, let me show you how I like to do it. There's different ways you can do this. I think it's easiest to use a prime factor tree. So that's how I'm going to show you how to do it here. So what you do is you put your number down, the number under the radical, and you're going to just start splitting it up into multiples. So I notice it's even, so I'm going to go ahead and divide by 2. So that would be 2 and 82. So that one's gone. Now 82 can be is divisible by 2, so that would be 2 and 41. 2 is prime. I can only break it down into 1 and 2, so I'm going to leave that alone. This other 2 is prime, and 41 is prime. So now what I'm going to do, since I'm simplifying a square root, I'm looking for pairs. So anything that has a pair will come out of the radical. So for example, this is a pair of 2's, and then here is 41 left over. So this is kind of cheesy, but this is how I can remember what comes out and what goes under. So think of the radical symbol as a little house, right? So here is the house. In order to come out of the house, you have to have a date. So 2's, they're going on a date, so they leave the house. 41 is single, so he's going to stay in the house, okay? So 41 stays in the house, and the 2's, they're on a date, they go out of the house. All right, so that is going to be written as 2 comes out, and each group comes out as just 1, 2. So that comes out as a 2, and then 41 is by itself, so it stays at home. So 2 square root 41 is the simplified radical form. So here is one of your answers. This is the simplified radical form. Now the second part says write your answer as a decimal rounded to the nearest hundredth. So if you're looking for an exact answer, this is it. If you're looking for an estimate, what you would do is put this in your calculator and find out what you get. So I'm going to do that. So let's see, the square root of 41 times 2, and it wants it to the nearest hundredth. So remember, that's 2 numbers after the decimal place. So when I did that, I'm going to use the squiggly equal sign. To me, it's approximately 12.806. So that will round to 81. Okay, so this would be your approximate answer. It's your approximation, okay? Remember, it's an approximation because it's rounded. All right, so be careful when you're doing your homework and make sure you give your answer in the form that it wants. If it wants an exact answer, you use the radical. If it wants an approximation, then you use the decimal, okay? And last for this section, find the midpoint of the line segment with end points -3, 7 and 5, 17. So the same coordinates we just had. Now we want to find the midpoint. So the midpoint, if you have a line segment, is the point that's exactly in the middle. It splits the line segment in half. So the formula for this, if you're looking for the middle, that's the average, right? So that's the way to think of it, is the average. So you're going to have an ordered pair. So what you're going to do is you're going to average the x values. So that means you add the x's and divide by 2. And you're going to average the y values. So you're going to add the y's and divide by 2. And that will give you your midpoint of the 2 points given. So let's see. x1, we have negative 3 plus x2 is 5 over 2. And then y1 is 7 plus y2 is 17 over 2. All right. So negative 3 plus 5, that's 2. 7 plus 17, that's 24. And so when we simplify these fractions, we get 1 comma 12. So 112 is the midpoint between the 2 points given, negative 3, 7, and 5, 17. Now, you can kind of look at your answer and see if it makes sense. So 1, 12. Is 1 between negative 3 and 5? Yes, it is. Is 12 between 7 and 17? Yes, it is. You can even go further and see if you can add the same thing each time, you know, if you want to check your work. To get from negative 3 to 1, I need to add 4. To get from 1 to 5, I need to add 4. So the x values work. Okay, now I'm going to do the same thing for the y values. Oops, let me go back and put that parentheses back. All right, so now if I want to check the y values, from 7 to 12, I add 5. From 12 to 17, I add 5. So it has the same pattern there as well. So this makes sense. So 112 is my midpoint. This is another formula you should memorize. So you should know this midpoint formula. You're just averaging the x's and the y's on your tests.